Part 284C3M1B7C8E13C9C6D3P38D19D7b52. And it's line 22f1fa19C3M1B7C8E13C9C6D3P38D19D7b52 PISEMA pulse crystal spectra 5G Wow Seti. There's the alien radio signal. This was done on May the 8th, 2013. Today is the 31st. So this is about Broadband-PISEMA solid-state M&R spectroscopy crystal pulses. The keyword is PDF results research for a UFO spaceship communications device in the WOW data. SAM14 is the pulse sequence to PISEMA. The data continues from a previous video. There's the line. Separated local field spectroscopy signals. May 8th, quote from PDF results, files on blog. Broadband-PISEMA solid-state NMR spectroscopy. Those are the name of the scientists. University of Michigan, USA. dx.doi.org. The measurement of heteronuclear dipolar couplings using a 2D separated local field technique, polarization, inversion, spin exchange at the magic angle PISEMA, is a unique way to determine the structure, dynamics, and topology of molecules in solid state. However, the resolution and sensitivity of PISEMA are highly dependent on the offset frequency of protons. To overcome this difficulty in this study, a broadband-PISEMA pulse sequence is proposed. Experimental data from a single crystal and simulated results suggest that the new sequence compensates the offset effects. This is accomplished using a pair of 180-degree pulses that invert the spin-locked magnetization of LNS nuclei after a certain number of SEMA cycles in the T1 period. In addition, unlike PISEMA, BB-PISEMA provides offset-independent dipolar coupling line shapes even when low RF fields are applied. So here's a graph here that says LS coupling, chemical shift, preparation, SEMA, acquisition, and then it's got mathematical equations on it. Let's see there. So this is a pulse sequence for spin exchange at magic angle. The original PISEMA sequence is a broadband SEMA or BB SEMA sequence that can be used in the T1 period of the PISEMA sequence to compensate the offset effects. The pi pulses in the sequence can be separated by several cycles of FFLG or flip-flop Lie-Goldberg, depending on the required spectral width and the dipolar coupling dimension. So there's PISEMA and BB PISEMA. And it's got 15N chemical shift ppm, and then it's got numbers 200 down to 50 on the bottom, and -6 to +6 on the left, and on the right it says 1H 15N dipolar coupling KHC, and it's -6 to 6 on that one. So that's figure 2 is the 2D correlation of 15N chemical shifts and 1H to 15N dipolar coupling of N-acetyl, 15N val, and 15N leucine single crystal at an arbitrary orientation with respect to the external magnetic field. A is PISEMA and B is BB PISEMA spectra. In 2D PISEMA spectrum, A was obtained from 128 T1 increments with a dwell time of 32.66 US, 4.18 ms acquisition, while the BB PISEMA spectrum was the resultant of 48 T1 increments with a dwell time of 40.86, and then it's got the funny U and the S, and a squiggly line, 1.961 ms acquisition. Other experimental parameters include a 500 and then the funny U and S, contact time for ramp CP, 4 scans, and a recycle delay of 3S. And this is kind of, so I'll make it a little bigger. So this is experimental and simulations. That almost looks like the Higgs signal upside down, right? So actually making a V like a Minkowski thing goes. PISEMA, BB PISEMA, percentage of H offset, scaling factor, BB SEMA. So I don't know what this is for. It's pi pulse power, so it's about the pulse power of something. Experimentally measured and simulated 1H to 15N dipolar coupling values as a function of 1H offset. The experimental values were measured from 2D PISEMA, open circles and open rectangles, and BB PISEMA, field circles and field rectangles. Spectra of NaVl single crystal obtained under the same experimental conditions. The solid line and dashed lines in A belong to two different 15N chemical shift resonances at 83.7 and 102.2 ppm of the spectrum, figure 2 respectively. The solid line and the dashed dotted lines in B were simulated for 175 kHz RF field strengths. Variation of the scaling factor with the ratio of the RF power used for the pi and LG pulses in the BB PISEMA. In the simulations, 100 kHz RF field was used for LG and the pi pulse power was varied. So there's site A, site B. 1H to 15N dipolar coupling. Spectra obtained at different 1H offset values from PISEMA. A and BB PISEMA sites A and B correspond to a 15N chemical shift value of 83.7 and 102.2 ppm respectively. This one here is a variation of experimentally measured 1H to 15N dipolar coupling values as a value of 15N offset in PISEMA dashed lines and BB PISEMA solid line sequences. Open PISEMA and filled BB PISEMA circles correspond to the site A at 83.7 ppm, and open PISEMA and filled BB PISEMA squares correspond to the site B at 102.2 ppm. That's from www.sciencedirect.com. Okay, and the next video will probably be about the same pulse thing as well. Thanks for watching.